open. Today we're talking about airfield lighting products and service requirements specifications. Part 2 of our AGL service and support. Our expert panel today, I'm so honored that you gentlemen join us as for TMS Tuesdays, and by the way, I would welcome if there are any female practitioners who would like to join us. You're always welcome, because we are underrepresented in our TMS Tuesdays. So today we have Tony Smith, of course, inventor of the PAPI and an original member of the team. Carl Johnson, who's most recent joiner of the team, consultant and expert specialist that I've known for many years through my work in North America, and very much respected practitioner in that market, based out of Florida. Stuart Ford, who is well known to you, again expert, and we were talking and the highly knowledgeable practitioner in the field of airfield lighting, working as a consultant now, but spent many years with Kraus Heinz. And Keith Costel, who will be presenting today. Keith, who is the cornerstone of our TMS Tuesdays, who has spent his lifetime really in aviation and airfield lighting, coming from the military into the civil sector, through ADB Safegate, and now is a training director of TMS Training Solutions, and still providing as much help as he's always done to the aviation industry, and today leading this webinar. So without any further ado, over to you, Keith.
Thank you very much, Robert. Well, as Robert explained, this is part 2 of our service support discussions, and pretty. I feel quite honoured actually to be in the same webinar as Tony, Seward, and Carl, who have vast years of experience out there. So who put that there? oh, okay. Oh yes, somebody. Yeah. Oh yes. So welcome to the dream team.
Right on, Keith.
Okay. So let us have a consideration of what we were actually talking about last month. We started and explained about service support, and had a good discussion. And we really was talking about after sales service in last month. And what is after sales? It's the follow-up support and resources for customers when they've purchased your product and their product, and it has been installed, commissioned, set to work, and it is now in the operational situation airside. But service support is a whole range of things, and one of the elements is to make sure that we satisfy the customer and give the customer exactly the support they need during the operational life of all the products, whoever have provided them. So that's we need to keep customers happy, because if customers are happy, they will keep coming back, and we all know the best customer you ever have is the one you've already got. And so that's the situation from last month. And what did we do when we, just excuse me while I'm just making, there we are. Service support. What we have to do is start at the beginning. And when we talk about after sales and overall service support, we have to go right the way back to the project definition stage. Because if we don't get the project definition phase sorted correctly, hence the equipment is selected, it's installed, it's commissioned, it's then tested, and it is deemed to be operationally serviceable and functional, compliant, then how on earth can we provide support thereafter? So we have to go right the way back. So we have to define the requirements right at the beginning in that project definition phase. Now, what we did last month is talk about 3 levels of service support collectively. And now the reality is then there are 5 levels in functional area. And these 5 levels of support, I'm going to briefly go through them and explain. And you'll see the bullet points here. Level one in terms, it's the basic level. If they have a customer, if an airfield has a problem, be it the operations, be it the maintenance personnel, then they want someone that they can contact to give them guidance and first line support. So that's kind of level 1. So a technician level of understanding whether it's the supplier of the lighting system, or it's a project team, or it's a tool such as we know we are talking fundamentally from TMS, we're talking about photometrics. So if it's a photometric output issue that it's not meeting the requirements, why? Well, there are quite a few reasons why, and it's basically split into 3 blocks of civil, mechanical, and electrical. And so that's the first level of like a telephone, a call center, telephone support, etc. Level 2 then is a little bit more advanced. If we cannot sort it with support with a telephone support, maybe a call out, maybe we have to go on site or have a look at some of the reasons why, because we know mechanical, electrical, civil issues directly, the environment, etc., directly affect the performance of light output. Level 3, we're now starting to say, oh, crikey, we still have a problem, guys. Maybe there was some elements associated with design. Maybe there was some element associated with the product choice or the interface. Now, when we're looking at a system, an AFL is a system, and that system is made up of component parts. And in the component parts, we have to put them all together. And when we put them all together, that's an interface. And when there's an interface, that's generally speaking where we start to have some operational issues, where those interfaces may not be working as fundamentally as we would wish. And so in level 3, we need to have a little bit more understanding, experience. So the level of person who is providing that support may be of a senior level rather than the general a general all-round engineer or technician. Level 4, then we go to a different stage again. Level 4 support is associated maybe with doing an audit, more in-depth understanding of the behind the design, etc. So that's the kind of level 4 in terms of service support. And level 5 then is more detailed. Maybe we need to really go back to understanding why the equipment is not performing in accordance with the requirement, whether it's the equipment of the lights themselves, whether it's the power, whether it's the control system, etc., or whether it's the tools that we're using on the ground. So there's a whole range of considerations. But when we're talking about a level 5, then we are talking about someone with years of experience, understanding, etc., including being able to look at ourselves and looking at the people. And so they are actually the reality of how we look at the whole service package, in that after sales, but by looking backwards at the beginning of a project. So let us just have a look at what we do in TMS as an example. In TMS, then we're looking at photometric output. And so that's ultimately what an AGL and AFL system does. It gives us light. But to give us light, we have to power it. And to power it, we need to be able to control it. So we will look at in a moment, we have these three areas of control, power, and the distribution, the light system itself. So looking at these 5 levels, who actually and how do we fit it into our organization in terms of tailor-made systems? Well, in fact, levels 1, 2, and 3 come under the photometric side of TMS photometrics, which is the MARMS technology. And therefore, the MARMS team will provide the levels 1, 2, and 3 service support. When it comes to the level 4 and level 5, it's more like consulting services or audits, or a more in-depth analysis into the research associated with the technologies. For example, we have moved from tungsten halogen to LED. We have moved in advanced surface movement guidance technologies. We've moved from single control lines to power line communication. That in itself has brought a lot of demands, because why? We have a problem collectively in an AGL system, because over the globe, over the world, then we have generally adopted a 6.6 amp constant current electrical system. Now, that's not exclusive. There are other systems out there in today's technology, but standardized around the world is a 6.6 amp constant current system. That 6.6 amp constant current system inherently has problems with earth leakage. And therefore, earth leakage, more than one earth, as we will all know who are involved in AGL, more than one earth on an AGL electrical circuit means that some of the lights will go out, or some of the lights will go dim, or maybe even flicker. So in itself, we have to have a little bit more in-depth knowledge. So when we're looking at level 4 and level 5, then we're talking about an experienced engineer providing that support. And when we're looking at an experienced engineer and we're looking at our team on the ground who are actually maintaining and operating our AGL, then are they competent? Because when I mean competent, I mean, can they justify their position in what they're actually doing on the ground? And that is what competency is all about. So training is another part of the level 5, that level 4, level 5 area. So, but there's a bit of a crossover. There's always going to be a crossover between, levels 1, 2, 3 and the levels 4 and 5. We don't just exclusively work in one particular area. We all share when we have information associated with what we find at level 4, we'd be sharing it with the people who are operating the level 1. So, it's about communication. So that's how we look at these 5 levels of service support. And when we're looking at that 6.6 amp constant current technology, just to remind you again, there's the power side. It has to be controlled. And then we have the distribution, the lighting circuit, that primary circuit. Now we know there are differences around the world with that lighting circuit. We know that the cable, for example, in a 6.6 constant current technology, depending on where we are in the world, it might be screen cable, it may be on-screen cable. That in itself brings different challenges and therefore can affect the light output. And if the light output is effective, that is when you need to have potentially a service support function in place. So each one of those areas in themselves, though, but the power control or the lighting itself, each have their own unique requirements. And in the control side, for example, in today's day and age, the active and use of PLC technology, for example, when we communicate across large distances between the control tower where the operator is of the control system, the air traffic controller, down to where the constant current regulators are in the, call it a power station, switch room, you know, power center, call it what you like, that the building, that's several kilometers away. And therefore we got to communicate in real time. So data communication techniques are used today rather than, you know, hard copper cable. That's the scenario that exists today. And when we're looking at those three areas of AGL, of control, power, lighting, then we have to consider what we've got in the field. We've got to look at the tools and test equipment that we use. We've got to look at all the processes and the people that are implementing and maintaining and operating the equipment. So when we're looking at, and let's take photometrics as an example. When we get photometrics, we have tools to be able to measure the light output in real time out in the field, out on the runway. And when we use those tools, they've got to be reliable, they've got to be accurate. And how do we communicate that information? Well, we capture the data, we analyze the data, and we present it. But once we capture the data, that has to be communicated to some kind of analysis system. Now we can do that in real time into the cloud. So there's real-time analysis. So we can present the data and we can check whether the light is giving the correct photometric output. That's the tools and test equipment. What if it goes wrong? That needs to be supported. So here, you know, TMS is a specialist in providing tools for such an application as that, there's photometric testing. So we need to be on tap, ready to be able to support the customer who are using the tools, the airport maintenance guys who are using those tools out in the field. Are they using the correct processes? Have they been trained on the equipment? Etc. So this is where about going back to the beginning. If you do not get the beginning correct, then you're not going to be able to provide an active and an efficient service support function. And one of the discussions that lots of us have is when a project is initiated, whether it's a greenfield or a brownfield project, whether or not it's just an upgrade, or it is a new facility, complete new facility, or we're changing the technologies from, for example, tungsten halogen to LED, then are the maintainers involved in the project? Invariably not. Now that's a fundamental problem, eh? How on earth can you provide a system to guys who are going to have to look after it throughout its operational life without involving them in the first place? Pretty fundamental incorrect. So that's where I say service support, whether it's the maintainers or the suppliers of the equipment and the tools, if they're not involved right at the beginning, or once we have installed, set the equipment to work, has it been tested? Does it meet the criteria? So how can you provide a service against an unknown factor? So this is where we have to really have a real good consideration in the future. We look at the negatives and the gaps we have at the moment and to fill these gaps in together. But if we're looking power, if we're looking control, if we're looking out in the field, the distribution and the lighting equipment itself, then each of them, each of those technical areas have their own service support requirements. And I've just put a few little, this slide just shows a project that I was involved with in Afghanistan, in Kabul. And in Kabul, then you can imagine it was a challenging project for obvious reasons. But how did we ensure that thereafter we could support the Kabul airfield? Is because we had to get everything correct in the first place, even down to getting the equipment that we were going to install on site. That was a challenge in itself. So site, and the final one here, look, I've put is site acceptance. Providing we can get all the equipment and we get it installed and we can get it set to work and we can get it tested and everything is working correctly, we've got to demonstrate and justify operational compliance. And that's what a site acceptance does. And it's that document that we can use to define the ongoing service support. So this was an extract directly out of that project. And in particular case, the substation, switch room, call it what you like, etc. It was a taxiway project. So, you know, it was about the site acceptance of the taxiway edge lights and its corresponding monitoring, controller monitoring system, etc. So a whole range. Now, out of that, we were able to then say, now you're going to need to have this level of ongoing operational support. I've kind of put the things together now to say, right, okay, let's have a look at who does what, and let's take the photometric side. On the photometrics, then tailor-made systems, TMS, on TMS photometrics, look, have the MARM set of equipment. So let me use that as an example. Then in the structure of how we provide this ongoing service support, level 1, 2, and 3 is directly associated with the MARMS technologies. And in that, there is the ability to have telephone support, the ability to have call out, so on-site support. There is the ability for us to with parts of the system, remote access to the equipment to find out why things are not working correctly for the tools, and etc. And of course, the equipment, the training and familiarization in the usage and the maintenance of the equipment itself. Then courses are provided. So they're the kind of level 1, 2, 3 from the tailor-made systems for the photometric side. When we go to the next level of support, then level 4 and level 5, that is what comes under TMS training solutions side, which is where, for example, we can provide you with audits. So we can do a pre-project audit, or for training. Do a training needs analysis on and the assessment of your people, for example. So this is where we kind of split the way we look at those 5 levels of service support. And in looking at those more in-depth levels of service support, that level 4 and the level 5, as I just mentioned there, training comes into it. We look at what's in the field, we look at all the tools and equipment, and so whilst the level 1, 2, 3, levels 1, 2, and 3 on the photometric tools is about tools, etc., and performance in the field with the processes and whether the people can operate and utilize the photometric tools. When we're looking at levels 4 and 5 within tailor-made systems, we are talking at a wider capability. We're talking, do we have the understanding, which we do, for the civil engineering side, which affects light output, the electrical engineering side, the mechanical engineering side, etc. And also to be able to familiarize and explain and train persons who are involved in design, involved in installation and commissioning, involved in maintenance, and also the regulatory groups. So across control, power, and distribution, the lighting side. And this is just a example of how we structure ourselves. So just a kind of summarizing really the level 1 support being frontline first, telephone support, and the persons, the technicians available to help you with that are specialist technicians. So hopefully with telephone support we can get you working again. And one of the aspects, and I'll just bring this up, where we can remotely access. And remotely access technology is available for us today to be able to do that. So the posh name is AR, augmented reality for remote maintenance. We can do that. When we look at level 2, we're going into a little bit more deeper consideration with more in-depth, the engineering elements is maybe a little bit more complex. Maybe we are talking about the sensors, say in photometrics, the sensors for capturing the data. Maybe we've got a problem with the sensors. Things go wrong in the field for a variety of reasons. Or is it the communication of that information to enable us to analyze and present it? So there's a little bit more in-depth requirements. So just as an explanation, I've just put in here, look, just a nice little slide which says assessment of the serviceability aspect. So this is the kind of level of understanding and support that we can do. When we go to that level 3, we get the what I mentioned already, the specialized technicians, where they are actually subject matter SMEs, they're called subject matter experts, because they're of a senior level, etc. That's available, and they normally are not involved frequently with the level 1 and 2, but it's when we have some more in-depth discussions that the subject matter experts need to be brought in and say, look, we have a problem with a particular sensor, or something associated with the sensor, or the communication. Is it the firmware? Is it the software, etc.? So a little bit more in-depth support. When it comes to, so this is just an explanation. These are subject matter experts. So it's just understanding the compliance. They're competent. They know the working practices and how that equipment should be, performing out in the field, etc. In the various environmental conditions, because we've got it from the Arctic, to the tropics. So those elements can affect us pretty dramatically. So that's the level 3. Level 4, more complex. Now we're starting to look at the aspects of can we support you at the front end of a project, in the middle of a project, at the back end of a project, and into its operational stage. So this is the level 4. It's the through life consideration. And so we're available there to help. When it comes to level 5, the more in depth, I've chosen out of the level 5, as an example, I've chosen training, because when we're looking at training, we've got to be able to analyze the people. So those 4 blocks that I mentioned: the field equipment, the tools, the processes, and the people. In the us, when we look in the mirror, am I competent to do the job that I've been given? If not, how can I analyze So that's what a training needs analysis is about. And I have to say, and I've put it at the bottom here, we use what is known as the ADDIE model, the ADDIE principle of looking at training. Now, ICAO have issued some directives associated with how training should be developed, how it should be structured, how it should be delivered, and how we are assessed. And when we look at that, it's called CBTA. To be quite honest, CBTA, competency-based training and assessment, is not new. It really is not new. I actually was first involved with competency-based training and assessment. Believe it or not, it was called objective training in those days, in 1971. Okay, that's how long it's been around. It's just that names change, you know, ways of explaining things have changed. But what we are doing in the aviation industry, in the civil aviation industry now, in terms of this level 5 support and with respect to training, is to structure it. So pilots have to go through phases of training. The person's aircrew have to go through phases of training. The people who maintain the aircraft have to go through the phases of training, and the aircraft support equipment. Everybody, the air traffic controllers, the electronics guys who look after the air traffic control equipment, the radars, the comms, etc., have to go through these phases of training. So we have these 4 phases now in initial training, qualification, refresher training, are the 3 main phases that we speak about. But there's also a 4th phase that is discussed, which is development training. For example, if guys are, you know, part of a shift maintenance team and then become the shift supervisor, or then eventually they'll move on to be the shift, you know, the maintenance manager. These are developments, and we have to have different considerations. The aspect which I would like to bring to your attention in here, though, is refresher training. There are some guidelines, and it comes from the aircraft engineering side. I know from my aircraft engineering days that if I was not actively working as an engineer on a particular model of aircraft, for 3 years, I would have to requalify myself on that particular aircraft. And it was a 3-year cycle. So there is some guidance associated with the time of doing refresher training. And it's generally is geared around 3 years. Now, some nations and some of their national authorities have said 2 years. Others have said 5 years, but the generic refresher training cycle is 3 years. Okay, so I can't be fixed on that, but all I'm saying is in ICAO, we have competency-based training where we give knowledge, we assess whether that person can apply the skills associated with the knowledge they've got. The main important thing is, do they have the correct attitude? Because going out there in the airfield, in the dark, in the cold, in the heat, is not always a fun time. You know, especially when things are going wrong and your friends have gone to the pub, gone out to, you know, for the evening to go dancing or see their girlfriends or go to, you know, on holiday with their families. You know, but you're working out on the airfield and you don't really want to be there, then you've got to have the correct attitude. So that comes under level 5. So coming back to where I started, is saying it starts at the beginning. Service support starts at the beginning. So we have to say, when we're looking at service support, was there an operational site acceptance criteria defined? Let's take the electrical side of an AGL system. we know that one of the fundamental limitations of a 6.6 amp constant current system is to have leakage to earth on our primary circuit. Earths, insulation resistance issues. So there's a minimum standard that we look at, and that minimum standard is based upon the system being designed for 5 kV, 5,000 volts, and that system then we accept it's living in the ground out on an airfield in different environmental conditions. So we do allow some earth leakage. 2 microamps for every transformer, isolating transformer, series transformer that we have out in the field, and 1 microamp for every 100 meters of primary cable, whether it's screened or unscreened cable that is used. So we can work out mathematically what our minimum acceptable insulation resistance is per circuit. Do you want your installation contractor and your to give you, which is 1 megohm above the calculated value? No, we have to define what an acceptable level is on a new installation, brand new installation. And so that's what we mean by site acceptance criteria. That is an electrical consideration, power electrical consideration. And there are many aspects. We check light output. Our light output needs to be according to the requirement. And let's take a runway center line. We know a runway center line, most of the runway center line lights are white in color, except when we get towards the end of the runway, they alternately red and white, and then all red. So we got whites, we've got reds out there. And so the light output on a runway center line, for example, is 5,000 candela, because that's how we measure light. I'm not going into what candela means, but it's the luminance and the distance we look at it at. But it's white light, 5,000 candela, we measure it. What if it's not 5,000? ICAO say, and it's generally accepted internationally, that if that light output falls to 50% of the requirement, and if it falls to 2,500 and below, then it is deemed to be unserviceable. But there is some maintenance guidelines. But there are many factors which affect light output, be it civil, mechanical, electrical considerations. But when we're looking at that, what was accepted at the beginning? What is the light output required when we have put a brand new lighting system out in the field? Was it 100% of design? 51% of design? For example, clearly we need to define what it is, because we need also to define then where we need to have external service support. So that's what I mean by we need to ensure at the beginning, what the criteria is. And so was there an ORAT? What is an ORAT? Well, an ORAT is operational ready and airport transfer, which is used collectively when we're doing an airport project. And basically it's taking the process for a newly constructed airport, or parts of, maybe we're upgrading from on a brownfield site. I think we understand the difference between greenfield and brownfield sites. Greenfield is brand new. Brownfield is an upgrade, basically. So most of our work is upgrades. So when we do an upgrade, then what's the criteria for checking the lights, for example, the photometric output of the lights? Is it 100%? Should it be 120% of the design? Because as soon as we put something out in the field, in the environment it lives in, it's going to deteriorate. It's going to have jet blast. It's going to have environmental deterioration. then we, for a touchdown zone, for example, then it's going to get battered in the touchdown zone area by wheel loadings. All those kind of considerations affect serviceability. But when we're looking at service support, where and when does an airport need to have external support? Because that's what we're talking about when we're talking about service support contracts. So I did a little a diagram here, so I'll go on to the next slide because I've explained it up a little bit. So you can see here, I've just said there's a process. Now, I don't want you to look at the particular timings here because this was for a specific project on an airport. It wasn't directly associated with AGL. So don't challenge the timings, please. That's under there because I extracted this from an airport project, but it's it's get it correct at the beginning. Get it correct at the beginning, because at the end, then we will have an operational system, and then our service support function may be minimized. That is required. So let's just consider that. So what I'm going to say now, look, guys, he said, look, that kind of, you've got questions, etc. The panels here, we've got this highly experienced panel, engineering panel with Tony, Seward, and Carl. So please bring your questions. Maybe I personally can start and say, Tony, do you have a comment to make about what we've discussed?
Putting Tony on the spot there. I'll let Tony just, before Tony answers that question, Keith, I just wanted to say, because we're now we're only a quarter of an hour to go. We will just introduce our next TMS Tuesday, so that you know what we're looking for. Because people will drop off over the question period. We are going to give ourselves a holiday in August, and our next TMS Tuesday is on September the 19th to fit around the various conferences and seminars and events that are happening already scheduled for September. And what we're talking about is, and this is very grateful to Tony, he's presenting the application of 21st century technology to airfield lighting applications. So we're really looking at the opportunities to harness these technologies in the service of visual aids guidance at our airports, linking in very closely to Airport 4.0, but also looking at, because recognizing some of our standards were written before the days of LEDs, before digital electronics were about. Look at the advances in computing and communications technologies since 1921, when I think Tony said, Keith said he started off in airfield lighting. We've got environmental considerations, because obviously a very, very critical factor we're all seeing with these record temperatures all over Europe at the moment. They will doubtless, we should be harnessing these technologies to give us environmental benefits. And we have technologies such as GPS and RTK, so which are already being harnessed for landing aids in place of ILS. But of course, the standards have somewhat lagged that, have not taken those into consideration, as far as I'm aware. So all of these things and many more, Tony will be exploring in our next TMS Tuesday on the 19th of September. So I hope that you can make that date. And so sorry to hijack your Q&A, Keith, but I don't want to go past our time and not have introduced our next very exciting webinar. So I don't know. I've forgotten the question now, Tony. Can you, Keith? Can you repeat it?
Yeah, I was just saying, for Tony, if Tony is, I can't see that. Are you there, Tony?
Yes.
Yeah, okay. Is to, give us your appreciation associated with one of the elements that is really, really important, because I know both Seward and Carl have a very strong view in the fact that starting at the beginning, then why should the maintenance people not be included at the beginning of a project? Because I know Seward and Carl very, very strong views on that. Your views on it, Tony?
Shall I tell you a true story? It's an aviation story, but it isn't actually about AGL or Airfield Lighting, but it illustrates the point, I think. A well-known airline some years ago decided it would initiate a new transatlantic service from an airport other than Heathrow, I think it was Birmingham, to somewhere like Chicago. They decided this was decided by the Board of Management. Now, the Board of Management had been restructured because it had been taken over by the chairman, was now an accountant. And he restructured the board and deleted from the management board, if you like, the chief pilot. There was no end user, if you like, on the board. The board set up this wonderful new idea of initiating a new transatlantic flight. They talked to Mr. Boeing, I think, and bought a lovely aeroplane, which they were assured would do the job. But still no input from the pilots. The project progressed. The aeroplane arrived. There'd been some enhancement of specification from the basic aircraft that was offered. The salespeople thought it was a good idea to add things in that time which were new, like you could actually telephone someone from the middle of the Atlantic. Wasn't that a good idea? We'll add that to the requirement. Back of seat, individual screens, so you could watch the television of your choice, and a whole lot of things that they kept adding goodies, which made the aircraft seem a much more attractive airplane to fly in. The airplane was delivered. It was only at that point that the pilots got their hands on the operating manuals and the data. And what they found out very quickly, they said to the board, we can't do this operation with this airplane, because all those things you've added have taken the airplane above maximum all-up weight. We can't do the sector without a refuel. Now, if they'd had a pilot there from day one, I suspect and suggest that problem would never have arisen. You need the end users, and in this case, what we're talking about now, I say the end users are the maintenance people. The end users need to be in right at the beginning and all the way through.
100%.
Absolutely.
Yeah,
and that's, as you say, the process of taking service level support, as you said, the 5-level process. Key to that is taking the requirements of criteria through to an site acceptance process. Carl, this is something I know you do a lot of, because you're often you're often calling on us to, as part of that site acceptance process. How do you get greater user or maintenance considerations taken into account in projects?
When we first meet with the airport staff, we ask to talk to maintenance. That's one of our first goals, is to get with them and find out how they maintain their airfields, so our designs can incorporate their maintenance practices. Because in the end, they're going to end up with the system, to maintain. And it's my job not only to give them a system that complies with the FAA requirements, but also something that they can maintain. I mean, you know, that's the whole goal right there. When my family flies into that airport, I want my family to be safe and the lights to be functional. So that's the goal of the system. And before I forget, one more time too, Keith brought up a very good thing about refresher training, in that I just completed my CPR training and hopefully I'll never need to use it. And according to the American Heart Association, I'm on a 2-year cycle. But OSHA and some other electrical training facilities say I should be retrained every year, because since I do not use that skill, I get rusty faster than somebody. Because there are a lot of, you know, there are nurses and so on in the class I take. Nurses may get an opportunity to use it, you know, every week, every month, or whatever in the hospital, or hopefully I never have to use it. So the refresher training for me is annually rather than every 2 years. So that was a good point that Keith brought up as well.
That's a great point, Carl. I mean, how many of us have had some kind of first aid medical training, you know, CPR, and yet if you're called upon it, I must admit it's probably 10, 15 years since I did it. And if I was actually called upon, I would struggle. And yet it's a fundamental skill to have. But you know, this is needed in all of our jobs, and it behoves us all to, you know, having achieved a certain level once doesn't mean you can do it tomorrow, and that's what's important. Tomorrow's important. Yesterday's interesting, but tomorrow's vital.
You have a comment about this, don't you?
Keith, yes. Are you referring to me?
Yes.
Yes, I did. And you did a great job of emphasizing these points. And I just want to again re-emphasize, Carl just alluded to it, you've alluded to it, the importance of the people who maintain the system to be aware of what they're looking for, what they're doing, and the importance of it. And that's why Carl mentioned they have meetings with the maintenance people right at the beginning. What we see typically happening is that does not happen, and we get to the acceptance area of a contract, and we have the airport management there, we have the installer there explaining the system, and those that have to maintain the system aren't even included in the meeting. And that's their first experience of knowing the importance of what they're doing. And if they don't know the importance of what they're doing, they're not going to be excited about doing their job. That's so fundamental. And so I just think that's worth bringing up again. But we see so much of that. And as Carl just alluded, the refresher training too. That's we've trained a lot of people, thousands of people over the years, but they need to come back and have a little refresher. So that's my message for today.
Well, the technology changes, doesn't it? I mean, look how on the control side, you know, in control systems engineering, you know, technology has moved the quickest, you know. We've moved in the power, you know, from the thyristor, you know, into this IGBT era, you know, for the power side, and then of course tungsten halogen, you know, the incandescent, to the LEDs, you know, in those three areas alone, the technologies have moved forward, and we all know with our mobile phones, you know, you put your mobile phone down and then you can't find it and you feel naked. You know, right. In today's day and age, but it wasn't long ago, was it, that we did not have those smartphones?
Yeah.
So that's the same.
Let's chip in something else about this, about the maintenance people need to be in at the beginning and all the way through. I think when the acceptance trials, pro forms, if you like, are being written, when it's going to be agreed what are going to be the acceptance criteria, the equipment, the maintenance people need to be in on that. For example, they need to be able to specify by what means, by what instrument or whatever is that going to be demonstrated. It should be probably the same equipment that they'll be using to monitor the equipment when they're maintaining it.
Yeah, the sad thing about the general industry is that specialist big consultancies, you know, with big bucks, you know, with lots of people with highly qualified persons, you know, with you know, qualifications all the way down their arm, but has never actually been on site.
Yeah.
And that's the reality, isn't it? And this is where competency-based training comes in to its own, really. Eh?
Yeah.
But
Yes.
when we're accepting an airport, as you just alluded to, when we have the acceptance tests, or when we have the messages from the manufacturer and the designer to the airport to tell them how to do the airport, the management typically would say, oh, we'll tell all the people how to do this and what to do. And you know what happens when you hear something and you transmit it to another level, and then it's transmitted to another level, the story doesn't contain the same emphasis, and it doesn't contain the same information.
No,
And
totally
so
different.
we want people that are out maintaining systems to be liking their work and know the real value of their work and be excited about it.
Yeah.
We're kind of excited about what we do. That's why we've done it for all these years, right, Keith?
That's
So,
correct. Yeah.
So that's the message.
Yeah.
Absolutely. Now, I've got a question here. There's some questions specifically on topics not related. There's very specific questions not on the topic we're discussing today. We'll take those offline. But Ilya has asked about the dramatic changes and revisions in maintenance budgets at airport, particularly with the application of new technologies for new equipment and training. And I don't suppose we're talking about increases in budgets.
I will I'll make an initial comment on that. You know, the application of the new technologies, and we've already I remember when the first generation of LED lights were installed on a taxiway edge, and the organization I was working in at the time had a leaflet and showing an engineer installing a light and saying, the next time we have to look at this light, his baby will be at university. And we know very well that's not the case. Mind you, we soon removed that leaflet, of course, out of the, but when the new technologies are introduced by the technologists, then this is the answer to the world. But the reality is, and let's take LEDs, yes, an LED will last many, many, many hours. They do deteriorate faster than was first thought, but it's the electronics, it's the driver, etc., associated with that LED, where main failure comes in, be it condensation inside the lighting fixture, be it heat, be it whatever the reasons behind it, then it's the electronics rather than the actual LED itself, which is a light emitting diode.
Exactly.
So that's where I'm saying is that, yes, budgets. And of course, we also have to appreciate that the world has been through a very difficult time in COVID. And we are talking about the OPEX funding and the CAPEX funding. And when it comes to the maintenance, then of course it falls into the middle when we start to look at funding. And also during that COVID period, how many of maintenance staff were retrenched, as it's called in some parts of the world. They were retrenched, and now they are now building up their maintenance teams again with limited budgets, because airports have been operating on empty buckets, no income. So unless they've been financially shrewd or had external funding for one reason or another, then they're having to recover. And we say we're recovering with flights, but are we recovering financially? There's still a lot of half-empty buckets out there.
Yeah.
Yes, you make a very important point, Keith, because we have seen a number of environmental changes with the as coming with the recovery post-COVID. We're seeing a change, generally speaking, in the mix of aviation. We're seeing an emergence of leisure recovering far faster than business travel, with the particularly strong in that sector as low-cost carriers. So there's inevitably less money available for the airports, and but the quantity of the aircraft is increasing again, and the demands on the aerodrome are just as high as they were before, but with less revenue. So it is becoming and as you pointed out, also with the churn of staff through the COVID period, we've lost a lot of experience. So it's never been more important to harness technologies and invest in training to ensure that that our industry, which has up until now had the reputation for being incredibly safe through a lot of hard work from many of those involved on this webinar today, and I'm talking about the audience as well. We've achieved a great position, but we need to maintain that and constantly seek to improve, don't we, Keith?
Yeah, entirely correct.
I think there's a point here to be made that with the pressure on all budgets, and particularly, it's always easy for top management just to slash things like training and maintenance. That's the easy bits. They think they can cut their costs. So if you're going to have reduced funding for maintenance, then it's important that your maintenance is done in a smart way. And there are tools that are available now that weren't available that can help you do that. So that can ameliorate at some point. You ought to maintain in a smart manner using the best technologies. And some of the data that TMS provide about how, if you put your management together in the right way, you can actually reduce the costs of doing it if you do it and do it right at the same time. I think that's important going forward.
We're reaching the end of our webinar, but Aidan has asked which of training AGL engineers to take part. So we have a large audience of AGL engineers. How should they approach in the current environment, addressing their ongoing training, whether they're electricians new to our world, or in fact they're consummate professionals who've been in the industry for years? If we could go through the group, and you could we could start off with Carl. With your projects, with your experience of working in America, how do you see people addressing their training needs going forward?
We see training done through professional organizations. We do some training through the Florida Airports Council and go to various airports and teach basic airfield electrical safety. AAAE has got the ACE program for airfield lighting maintenance, addresses it. Some of the airports where we do work, we actually go in and do specific training for their needs. And that's the summary of it. IES that's coming up in November would be a great place to go to make networking contacts and learn about training opportunities there. And I will turn it over to someone else since we're.
I'll just echo what Carl said, because he summed that up very, very well. I was just going to make one other point that Keith, you mentioned that the minimum service value of light output in ICAO is 50%. Well, here over in the FAA, it's 70. And I think that's trending in the right direction with all the capability and all the potential training we can do. And with LEDs, I think we could certainly say 70% is reasonable, and I could even think higher than that is reasonable if we treat it with the emphasis that we should.
Absolutely.
Okay.
I
Totally
know that's
agree.
a topic Tony feels very strongly about. You've mentioned to me your regret that we ever introduced the 50% serviceability concept.
Yeah, that was unfortunate. It was good intention, but unforeseen consequences.
Yeah.
The use of the 50% goes back to the late 70s when it was in the UK, and in fact my work showed that nothing like 50% was being achieved anywhere on a regular basis. Most airports never achieving 50%, not really knowing, and they'd had flight checks, I would say, and got their certificates on the flight check, and it was. And when I talked to the maintenance people, it was clear they had no concept beyond changing light bulbs when they failed. And perhaps if they saw the fittings were really, really dirty, going with a sort of damp rag and rubbing some of it off in the landing areas, touchdown areas on the runway, very little else done on maintenance. And we brought this to the visual aids panel and said, you know, this is a serious situation. We should at least give some indication that you do need to do some maintenance. And that 50% was really put in there to say, this is an absolute minimum. And the idea in the visual aids panel was that we do further work to establish better figures, but at least give the maintenance people something to aim at. At that time, if they'd all achieved 50%, it would have been an improvement. But it was always intended that we should further develop it. And of course, it got lost somewhere. The work was never done.
Thank you, Tony. And so I'll give the last word to our #1 practitioner of changing light bulbs, by his own admission, Keith Costle.
Yeah, I'll reiterate everything that you guys have just said, but it was so interesting because a colleague of mine, sadly he's passed away now, he was a language teacher and experienced across many languages. Language skills was fantastic. And he used to say, oh, this is my English mate, Keith. By the way, he changes the bulbs on the airfield. And I used to say, yeah, that's what I do. That's what I do. Because that's what people kind of thought. They saw all these pretty lights. You jump in an aircraft, they look out the window, we see all these pretty lights. And when I fly anywhere with my wife, the first thing, I can't help it, I sit there, I look out the window, and the first thing she says to me is, don't mention the lights. So yeah, I totally agree with all you guys, you know, 100%, you know. So.
Okay, well, look, thank you very much, gentlemen, for another very illuminating, of course, and informative TMS Tuesday. As I said, the next one we're talking about applying these 21st century technologies to our airfield lighting applications and looking at some of the standards involved and the opportunities for our industry. And that's and Keith will Tony will be leading that one and giving us his leading us with his thoughts for the future. As Keith points out there, you cannot manage what you don't measure. Never forget that. We're going to leave you now. I'd like to thank Tony. I'd like to thank Carl, Seward, and of course Keith for their presentations and contributions today. Also in the background there, let's not forget Damon and Felicity, who've arranged this webinar for you all today. I'd like to wish you all a enjoyable summer holiday. If indeed it is your summer, enjoy your summer holiday. We're going to have a summer holiday now in August, and we'll see you back again on Tuesday, the 19th of September at 2 o'clock. So thank you very much, and see you all in September. Goodbye.
Cheers.
Thank you.